Not that I can write today clearly because the word geometry is totally crazy there. All right, we're looking at winding up our semester. Things are really starting to wrap up and wind down quickly, in case you didn't notice. This is week 12. Take a second and breathe. We're only meeting through week 14, so it's coming fast. A couple of you have asked me about grading, and I am working on it. I finally got stuff updated in D2L and all lined out, so I'm working on it, I promise. You will have grades, hopefully the majority of your grades before Thanksgiving, but for sure by December 1st. And remembering that the test grades and the project grades are the most important. Those are the ones I normally try to grade first so that you get feedback on those. And homework I don't really stress out about because it's just kind of a you did it, you understood it kind of thing. It's for practice, so we will get you grades, I promise. My grader and I are both behind. But looking at the rest of the semester, this is what we put up the other day. So we have finished all the proofs that I intend to do with us. If you have a specific question and you want to, you can come ask me. I can do a Zoom meeting, whatever. That's fine. These are, this is what we did last week. Due on November the 19th. That's not this Thursday, but next Thursday. Okay. So if you need them, there are hints. I posted in D2L on week 11. Things like, okay, well, think about doing it this way. Maybe they help you, maybe they don't, but I'm hoping that they push you in the right direction. Today, we kind of have a hodgepodge of stuff. We're going to look at the Pythagorean Theorem and next, but first I want to look at questions on your, well, I want to look at the entire process for how you go about taking your state exam for math, okay? Because I think that that's something that people get into. Maybe you're like close to your student teaching semester and you're like, oh my gosh, I don't know what to do and I don't know who to talk to and all that. The good thing is that I'm one of the people you can talk to about this. So you already know me and we already have a connection. So I can help you out with some of that stuff. 3D drawings and stuff, we'll get to that. And then the video day, somebody asked me about this. I've actually switched your content from the syllabus. We're supposed to be talking about area, surface area, and volume this week, but I switched it. We're actually on Pythagorean Theorem. And that's because the videos that I already have created are on area, surface area, volume. So I might as well put that off for a week and just use videos I've already created. So they will be pre-recorded, or they are pre-recorded videos. I've already got them in D2L. I just haven't activated week 13 yet, but I intend to, okay? So this is next Tuesday, 11/17. We are not meeting face-to-face. I will not Zoom that day, okay? So nobody shows up a week from today. Make sure you know that. Instead, everybody will go online onto D2L week 13 and watch those videos, okay? It's all about surface area and stuff like that. Okay. You also need to work on your presentations next Tuesday while you're not here with me, and turn in your semester-long project write-up, okay? That's due on Tuesday. You've had it for like 3 months now, so hopefully you're making progress. And then next Thursday, that's when your presentations are due. Well, technically Friday now, but we will do review for the exam, and then your exam 2 is the week of Thanksgiving on Tuesday. Yes, sir.
You're not here next Tuesday?
I am not here next Tuesday, so do not come to class. That door will not be unlocked. Okay. I'll probably actually be around. Like I said, I'm going out of town this weekend. I don't have control completely over when we come back, but I expect we'll be back really late Monday night. So I'll probably be around if you want to come by my office hours or drop in or send me a message or whatever. I'm glad to respond to that. I'll be nearby. I'm just not holding classes that day because I can't guarantee. Absolutely, I'll be here. So, all right. Okay, let's talk a little bit about a couple of these things. First of all, the write-up that's due next Tuesday. I will make sure of this date being that this is open for you to submit before next week. Mary's asking me, what about this non-internet source? Okay, so what I mean by a non-internet source is that some people, for instance, might go on to Teachers Pay Teachers and pay a couple of bucks to get an activity from somebody. Okay, that's an internet source. Okay, or if you happen to see some really cool Wikipedia page that talks about things you can do with dice, that's an internet source. So what I mean by non-internet is either a book. We talked about that the library is doing, you can't go into the curriculum library right now, but they will check it out to you. Like, what? Oh, they let you in the other day? Oh,
I
nice.
took down all the tape when they stopped doing tickets to get in the door.
Oh, nice. Okay. So you can go in there. So look around. There's books up there. In particular, book sources for manipulatives. I would say one of my favorites is the super source books. Oh, she's got one in her hand. Can I steal it for a second? They've got them on all kinds of stuff at all kinds of grade levels. Thank you, ma'am. Only touched the corner right here.
No, it's fine.
Okay, so for instance, this one, did you get this from the library?
Yeah.
Okay. Miss Ashley checked out from the library. I should have done that because I see the thing right there. It's the super source book on geoboards, which is a really cool manipulative we're going to see about rubber bands in your presentation. Cool. And this one particular one is grades 3 through 4. They have them broken down by grade band. So if you have a more traditional manipulative like geoboards, they probably have some stuff up there, tangrams, stuff like that. So any kind of book like that, you're good. Also, non-internet sources include journals. Now, this is tricky because most journals have been put online now, okay? But the difference being that an internet source is not, in general, is not peer-reviewed, and so it hasn't been like refereed. So there's no telling how good that material is. But if it's gone into a peer-reviewed journal, then those have been checked, so to speak. So these journals in particular, there's stuff like Teaching Children Math, the middle school math teacher, okay, and the last one, I think the last one is called Mathematics Teacher. Now, these are all NCTM journals, National Council for Teachers of Mathematics, NCTM. So they're all NCTM journals, and they're all peer-reviewed. They're all really good stuff. If you find an article in there, even if you find it online, it's still a peer-reviewed journal, so I don't consider it an internet source, if that makes sense. So any of that stuff would be good. Sometimes they want to charge you to get into some of their stuff, so just be really careful about that. Don't pay for junk. Sometimes I have copies of things that I can look for you, okay? So you need 2 activities. One can be an internet source, and one needs to be a not internet source. Okay. Yes, so Mary says she has a brother who's a math teacher. I'm reading your private message out loud. I'm sorry, Mary. Brother is a math teacher, 6th grade. he has a lesson that's on string art, because that's her thing. Her topic is string art. And would that work? As long as that is something that he actually has, he probably got it from like a super source or something like that. So it's an actual document, it's actually been vetted, then yes, that's okay. Document for a school, does that work? Okay, so a document for a school, you have to be a little bit careful, but if it has citation information, then yes, it will be fine. So you need at least one, I would call it a book source. Okay, at least one. So yes, if they cites what they use, absolutely. So if they have a citation with such and such by so-and-so, volume such and such, published by so-and-so, absolutely. If you have the citation and you can give that to me, then that counts as a not internet source. Yes, absolutely. Okay. Everybody understand the difference? So you need one of each. So hopefully you've been trying to, Mary's actually been emailing me privately emails and saying, okay, what about this? I'm stuck on that. So she's actually been searching, and depending on your topic, sometimes it's not as easy to find a non-internet source. So you need one of each, or you need at least one book. If you have two books, both of yours are super sources, you're fine. But if you have one book activity, one internet activity, that's fine too. That's fine. Yeah, the link is good. No worries. Okay, great. Thank you. Awesome. So that's about that, the semester-long project. Coming up quickly. That means the semester is almost done. Okay, the other thing I want to clarify is test 2. We're going to run it just like we did test 1. Okay, so in other words, I have basically 3 options. One is Binion 329, which is our classroom here in Commerce. It only holds 10 people with the COVID numbers. It actually holds 35, guys, but they'll only let me put 10 in here. Okay, so I need to know this test is 2 weeks from today, right? 1 week from today, we're not meeting at all. Your test is 2 weeks from today. So Maria?
Will it be normal class times?
Yes, this isn't our normal class time. This is actually, this is November 24th. It is our very last face-to-face class meeting for the semester, right?
Are you doing the list again?
Yes, that's where I'm headed. Thank you. I need a list. So if you, for instance, see, Christina's already saying, and first priority comes to people who are normally in commerce anyway, right? So if you are already in here and you plan to be in here, you tested in here for test 1, then I am good for holding a slot for you in test number 2. Okay. So yes, 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 yes. Okay. We'll figure out other people as they come in. I figured that would be the case. My diehard commerce people want to test in person, and that's fine. I also see Christina would like to come in commerce. You were here last time. Alexis, you were here last time. That's fine. Do the way I did the previous exam. Yes, Mary. Okay, so test option number 2. Ferguson 308. Okay, they hold 8 people. Together, these 2 locations can hold all of our people at the same time. It's terrible. We wouldn't normally have to do that. And test number 3 is an alternate testing site. Okay, and last time these were Samantha, as you tested there in Navarro, Mary, you did in Mesquite, and one other person. Oh man. Cameron. Okay. So the three of you, I'm assuming you will do just like you did last time. Thank you, Mary. Thank you, Samantha. Perfect. Okay. So that works out great for me. If somebody else needs an alternate testing site, because it is the week of Thanksgiving, if you're going to be, I don't know, in Timbuktu, we might be able to find you an alternate testing location. Christina, I have you here. Alexis, I have you here. Garrett, I have you here. I'm assuming DeMondre is going to want to be here. Okay. So, other than that, we will work it out. Okay, you guys let me know. And I've already posted it in D2L that I need to know your plans. DeMondre says yes. Okay, good. Perfect. I've got you on my list. And then I need to know your plan by the end of, let's say by next week this time. So if you have not already, I just gave you the nod, then we need to verify because I have to know where to send which tests. Okay, perfect. All right, good, good, good. Okay. That's the other thing I wanted to verify. Perfect. All right, exam 2, 24th, this is 25th. Your discussion board posts are due by Wednesday, but you can do them early. It's already posted, no worries. I'll get your grades to you by December 1st. Video about the final exam review will be that day, and I'll do a Zoom meeting on December 3rd. Now remember, your final exam is optional, and once you see your grades, you'll have to take a quiz. That's actually your last grade in the class unless you're taking the final exam. So the quiz tells me, yes, I plan to take the final, or no, I don't plan. All right. Yay. Reflections on D2L. Perfect. All right. My plan is today to finish fleshing out the last few weeks of the semester so that, for instance, the video for next week will already be up. So if you want to go ahead and pre-watch that or whatever, get a head start. I'm going to try super hard to flesh the rest of the semester, except for a review week and finals. Flesh that out today, this afternoon, because I already started on it. And I'm going to finish it, dang it. Okay, so that's my plan. And then you can work on those at your own pace, as long as you finish it in time for whatever deadline it has. Okay, everybody good? All right. Perfect. Okay, Pythagorean Theorem. Guess what, guys? I'm not going to spend a ton of time on Pythagorean Theorem. You know why? Because you guys know Pythagorean Theorem, don't you? Okay, so a squared plus b squared equals c squared. That guy. Now, you know when, well, I hope you know, y'all tell me, when can I use this particular formula?
Right triangle.
This works with right triangles. Okay, and it's a way for me to find one of the leg lengths, right? For instance, they're perfect, or they're special right triangles. You might have heard of the 45, 45, 90. Yeah. That guy has special properties. You probably saw them if you've taken a trig class. There's also a 30, 60, 90. Has special properties. But they don't have to be these special guys, right triangle theory says, exactly. They don't have to be these special triangles. It could also be something like these are special. It could also be something like a 20 degree, 70 degree, 90 degree, right? And what I know is that if I am given, let's say that, two sides of a right triangle, I can find the third. Using the Pythagorean theorem. Everybody knows that, right? And you all know how to substitute into a squared plus b squared equals c squared. So I'm not belaboring that point. I'm instead going to talk to you about a little bit of background information for the Pythagorean theorem. So for instance, who's it named after? Pythagoras. Why?
He didn't know what to do.
Ah, not true. That's what we always think, right? It's a fallacy. Okay, so not your fault. I'll walk you right into it. Okay, normally things that hold people's names, it's because that person proved it or that person developed it or came up with it to begin with, but this is not true. There is actually evidence that shows the ancient Chinese people, and the Greeks knew about it, but the Chinese are older, okay, had this relationship. Okay. So they had this relationship. They already knew about these, we call them Pythagorean triples, like 3, 4, 5. If one side is a 3 inches and the other side is 3 inches, then the hypotenuse has to be 5 inches. It's called a Pythagorean triple. We see them all the time. So the ancient Chinese people actually knew about this. They already had it. Ryan says the ancient Greeks, which is true. Euclid wrote something called the Elements. We maybe mentioned that in here. It's like all these books full of postulates and things that propositions that he proved about lines and planes and things like that. Inside of that, he mentions Pythagorean triples and the Pythagorean theorem. So why does stinking Pythagoras get his name on it?
He published it.
He what?
He's the one that-
It is the ancient version of publishing. Yes. So nowadays, if I publish something, I'm probably going to get my name on it, right? If I put it out there in fine print and make sure that I'm the first one who's done it. So it's like that. But the thing is, they didn't necessarily publish back then. He just had a lot of followers. Okay. So they're called Pythagoreans. Okay. These people who followed him like a cult, basically. And they thought numbers are everywhere and numbers are everything. And there's a name, a number that we can assign to the universe. And there's a number I can assign to girl. And there's a number I can assign to boy. So they were really into their numbers. And he had a lot of followers and they did a lot of stuff with triangles. Okay. And they actually did a lot of work with this particular a squared plus b squared equals c squared. And this is what happened to them. One day, they're working along and they do something to this effect. Instead of 3, 4, 5, let's say I have a 4 squared plus 5 squared equals c squared. What about that? 16 plus 25 equals c squared. This is going to be what? 41? Check my arithmetic. It's all fun and games when we got 3, 4, 5 because that comes out nice and pretty. But what happens here? All for C? Square root both sides? Yeah. What is that?
Not pretty.
Not pretty, right? In fact, this is like some of the initial evidence that the Pythagoreans had that not all numbers are rational. Okay, they really thought everything we need to express, we can express as a ratio. Okay, even stuff that was over here, it's okay if it comes out like 2 divided by 3 because that's a fraction, right? Fractions are okay. 2, 3, good. Okay, square root of 41, bad. Okay, that's the way that they thought. Yes, sir.
Interesting fact, you can actually ratio a person's face face across is like
Hmm.
5 of your eyes, or your nose is halfway between your jawline.
Are you working? You're not working on the golden ratio, are you? That's not one of my topics in here. No. My math history class, they work on golden ratio. That's one of the topics for them. And you can see like Leonardo da Vinci had that perfect man drawing and stuff like that. And he did a lot of those kinds of ratios, like how far is it from your elbow to your wrist versus the length of your hand? How many hand lengths go into that, basically? Kind of like the diameter to the circumference thing, okay? But he did that all over the body, the whole entire body. So it is really interesting. And they have something called the golden ratio that basically says a perfect person will have these kinds of ratios, these kinds of dimensions in their numbers, basically, which ends up being around 1.67 is the golden ratio. So it's really cool. Yeah, there's a lot of stuff out there. That's a little side note, but it's a cool side note, so I'm good with it. Okay. All right. So the Pythagoreans, what's wrong?
This right here, is that
Had this relationship. Yes, I'm sorry. Ancient Chinese people had this relationship. I'm like, what can't she read? She just keeps getting closer and closer to the board. Yep. All right. So because they spent so much time with it, because he had so many followers who were really vocal, okay? In fact, the finding of something like square root of 41 from this particular relationship, it actually caused people to commit suicide, okay? I know, because they were that serious about their numbers, and things needed to fit just right in their world, and this number doesn't fit right in my world, okay? So square root of 41 doesn't fit right. And the reason why we now know, nowadays we just go, square root of 41, leave it alone, right? Can't simplify that, leave it alone. Or if you were really serious about it, you might stick that on your calculator and get a decimal, which is what, 6.40312. She kept on going. It's a not ending decimal, right? Not terminating. What are those called? What kind of numbers are those? Starts with an I.
Irrational.
There we go. Irrational. And nowadays we just say, stick a square root on it, keep on going, we don't care. But back then you have to realize this is a brand new discovery, right? It's a big deal, okay? So he basically gets his name on it because they made the most stink, basically. Okay, they publicized it the most, so that's why he gets his name on it, okay? There's also actually evidence that the ancient Babylonians had this, which they're between the Tigris and Euphrates, like right around the Arabian Peninsula and near Asia, okay? And they used clay tablets. Have y'all studied the Babylonians in like 1350 or 1351? Okay, they used clay tablets and they used a stylus and they like marked in it like a stick in the clay. And so they didn't really even have a really great written system of numbers or words or anything. But there's evidence in their clay tablets that they had this relationship also. And they're about probably 2,000 years BC before Christ. So long time ago. Before Pythagoras, who was somewhere in the, I think 1200s for Pythagoras. So I'm not good on dates, but way before he had it. Okay. So we know, give me two sides, I can find the third side. What about this? If you know a triangle fits into a squared plus b squared equals c squared, then you know what about the triangle? Good. Is a right triangle. Very nice. Okay. So if you can see this relationship happening, then you know you must have a right triangle. That's the converse, right? The opposite statement. First, we start with a right triangle, and we develop it out to be, okay, it's got this a squared plus b squared equals c squared thing. And now we're saying, okay, we have a squared plus b squared equals c squared. that must mean we got a right triangle. So you can prove it both directions. We're only going to prove it the first direction. But in your book, they spend a lot of time talking about it. The other thing that they spend some time working on in your book with this, and this is all of chapter 9 in your book. They spend time on the 30, 60, 90. I'm just not going to spend time on that. They do something called, well, they use it for coordinate geometry, which you would do in algebra and stuff like that. Oh, here it is. The ladder climb. So they work out a bunch of word problem type things. Okay, so this is page 491 of my book, but the ladder climb, lots of that. And we can end up using it in circles, which ties in with stuff we did for this exam, right? So somewhere along your way, remember that we had this postulate. If I have a radius of a circle and I have a line that is tangent to it, what did we know about that? They meet at right angles. So then if I have a side, a third side to that particular triangle, then I know this triangle, if I put letters on it, A, B, and C, that triangle is a right triangle. So if I wanted to, if they gave me some numbers, I could figure out lengths of these guys. I'm going to stick with nice and easy. If this is a 3 and this is a 4, then the hypotenuse here is a 5, right? Okay. So your book goes a lot into that. What I'm going to do is I'm going to work with you to show a proof, because we just did proofs and proofs are fun. But we're going to do a nice geometric proof for it. Instead of having to work so much with logical step, we can write that out if you want to. But I want you to see the proof for a squared plus b squared equals c squared. Have y'all done that before? Guess what? This is really cool to me. Pythagorean theorem, for some reason, people are just fascinated by it, and they play with it, and they work little problems with it. And for some reason, people want to prove it. How many proofs do you think there are out there? Yeah. 10? 20? 100? 200? There are over 300 individual proofs. I know. That indeed, if you have a right triangle, this relationship works. Over 300 people, different situations. Can you imagine looking and going, hey, what about this approach to it? What about that approach to it? So people just keep on doing it. And an interesting one, the one we're going to do, President Garfield, who was not a mathematician, has his own. And he was not a mathematician. It was just interesting to him. And so, huh?
I'm trying to remember if he was one of the presidents that was assassinated.
Oh, you know, I think he might have been, actually. Yeah,
I think he was bought into presidency.
I don't know. So the thing about this, though, is that back in the olden days, not President Garfield's day, but before that, way before that, people were like paid to be mathematicians, just sit around and come up with stuff and think about it. So some of these we can go, okay, some royalty, some king, some duke, whatever, paid for their mathematician to come up with something new. Okay, that's cool. But this is just the president, and he's just hanging around going, hey, what about that Pythagorean theorem? I don't know. So it's interesting. what he did was he created 3 right triangles. So I'm going to give you, and his is very, he wrote it out in words, okay? So I'm going to paraphrase, and then we'll see what it looks like. So he says you need 3 right triangles. 2 are congruent. And the third is an isosceles right triangle. Okay. Put them together in such a way, and I'm going to say use them to create a trapezoid. So this is the premise of his proof. Okay. So he has this picture. He's making 3 right triangles, and he's making them create a trapezoid. And if you do it right, and you have a nice picture, then you can prove the Pythagorean theorem, and that's what he said. So let's talk about that. That's all language we know. It's just a lot going on. 2 right triangles that are congruent. What does that mean for me? How do I have congruent right triangles?
The same size.
Same size and same shape, right? That's congruent. So the way that I do this, and you can draw this picture in different ways, but the way I do it is I draw a tall, skinny right triangle. Standing up is the way I have it in Webster brain. And I'll call the short side here A, and the tall leg B, and then the hypotenuse is my C, because that's just the standard notations we would normally use, okay? And this is going to be one of my congruent triangles. So what I want to do is I want to draw another triangle that looks like this, but what I'm going to do is I'm going to lay him down on his back here. So B is going to come out here straight along with the A. It's going to be collinear with that side A. Something like that.
Mine aren't congruent.
I know, mine's never congruent. You know, it will be because we're going to mark them and they're going to say these are congruent. Okay, so if I lay him down on his back here, then this piece right here is what? B. And this vertical piece is A. And then this piece right here is C. Okay, so look at it like this. This one is perpendicular to this one, right? And this side down here is perpendicular to this side. So what do we know about this side B and this side A? They're parallel. Does everybody agree? Because perpendicular and then perpendicular, that's 180 degrees. That means they have to have the same slope. Okay, so he's creating this in such a way that it has to be, okay? So in other words, this is all lined up. This has to be congruent to this guy. So I've got my 2 triangles. And then I need a trapezoid. So what do y'all think?
Just connect.
Yeah, connect the dots, right? So go from the vertex up here on this triangle down here to this vertex right here, okay? That makes me a trapezoid because these are parallel and a trapezoid has exactly one set of parallel sides, right? So this is a trapezoid. And then what about this third triangle here?
Isosceles because the 2 legs are length C.
He told me it's a right triangle, so I'm making it right. And it is isosceles because these 2 sides are the same, C and C, right? So this is my third triangle. You see it? Now, once you see it, it's like, oh, okay, that's cool. What the premise is that he's going to use once he has this picture drawn is he's going to say, okay, what we need to do is we need to find the area of all 3 triangles. That's easy enough, right? So add up all area of triangles and set that equal to, what do you think? The area of the triangles is going to be equal to what? The area of the trapezoid. They hold the same space, right? So it's that whole idea of, as long as I don't take anything away, I'm not losing anything. Those two spaces must be congruent, right? The areas must be congruent. So is equal to the area of the trapezoid. Okay, that's the whole idea he's got going on here. So it's actually pretty smart. I mean, I wouldn't think to do this. Okay, so talk to me about areas of triangle. How do I find that? There's a formula.
1/2 base times height.
Okay, 1/2 the base times the height. Everybody agree? And then what about an area of a trapezoid? We did that, but it's been a while. It was when we were doing quadrilaterals, right? It's what? 1/2 of. It actually looks a lot like this. 1/2 of, I'm gonna put that in parentheses.
Base 1 plus base 2 times height.
Base 1 plus base 2. Basically, remember we added together the bases and averaged them, divide by 2, and then multiply that by the height. So that's the area of the trapezoid. And if you were doing this on a test, I would not expect you to necessarily memorize the trapezoid formula. I don't care. Area of a trapezoid is nice if you know it, but you don't have to. All right, so let's do it. We're going to sum up all the areas of the triangle. So this triangle right here, 1/2, what's his base? A. What's his height? I'm doing this little triangle right here. B, okay. Plus, so I've got this one. What's this guy right here, the other congruent one?
1/2 base 1.
It better be the same exact thing, right? 1/2 the A times the B, because they're congruent, so their areas are congruent also. And then, so that gives me this triangle. And then what about this triangle right here? His base is C, and his height is C. All right, good. So we agree with that? So base here, C, height here, C. And it doesn't matter if you had flipped that triangle around, the area is the same. It doesn't matter if I rotated or reflected or whatever. Okay, so that's the sum of all my areas. Now, let's be careful about, this is going to be equal to, that's the area of all the sum of all the areas of the triangles. Okay, now I need to set that equal to the area of the entire trapezoid, which we said was 1/2. Now be careful. Let me rotate my picture just a minute. Normally we call these parallel sides the bases, right? Okay, so I need to add them together and divide by 2. So one of these bases is A, and one of these bases is B. Does everybody agree? All right. So base 1 is A, base 2 is B. So this just becomes 1/2 times A plus B. And then, again, let me rotate my picture. These are my bases. The height is always the vertical, right? The perpendicular height, anytime we do this. And so what is this height? A plus B. That's the genius of it, right? Because of the way he's set up this triangle and this triangle, it ends up being the same, A plus B. Just genius. And that's his height. So this is his bases averaged. This is his height. All right, so I need to do a little bit of arithmetic, or not arithmetic, algebra here is what it boils down to. So this is 1/2 AB. This is 1/2 AB. So if I have a half of something and a half of something, then I have a whole something, right? Okay, so all of this together gives me AB. All right. Okay. And then what about this piece right here? It's 1/2 times C times C.
1/2 C squared.
Okay. 1/2 C squared. See, anything times itself is that thing squared, right? C times C is C squared. All right. That's the left-hand side is equal to, now I'm just going to write this half out here, and I'm going to go ahead and distribute this through. So this is just a binomial times itself, right? Binomial squared. So when I do this, if you FOIL it or distribute it or however you think, I get a squared plus ab. And then here in the inside, I get plus ab. All right. And then I get plus b squared. Now, if you were really good in your algebra class, you probably know that you wouldn't have to multiply out this binomial squared. You would know it's a squared plus 2ab plus b squared, right? There's a formula for that. But if you don't, it's okay. We can get there. So a squared plus 2ab plus b squared. I'm just cleaning that up, combining my like terms. Okay. Now, what do I need to do? Can't really do anything to the left side. AB plus 1/2 c squared equals.
We can distribute.
But on the right side, I can distribute, right? Good. Okay, so 1/2 a squared. What's 1/2 times 2? 1/2 times 2. 2 divided by 2. 1. Okay, so this is a plus AB. Everybody agree? And then plus 1/2 b squared. So this is just algebra 1-ish stuff now. Okay. All right, now look at this. On the left-hand side, I have an AB, and on the right-hand side, I have an AB. What can I do with that? Subtract AB from both sides, right? And AB minus AB is 0, and AB minus AB is 0, so those just go away. That's nice. And look how this falls out. 1/2 c squared equals 1/2 a squared plus 1/2 b squared. Gosh, that looks a lot like what I want it to look like. What would we like to do to it?
We'll just have that too.
Okay, good. If I could just get rid of those halves, right? And I do that by multiplying everything by 2. Okay. And then I have c squared equals a squared plus b squared. And we know we can rearrange that and write a squared plus b squared equals c squared. It doesn't matter. Look how cool that is. So he took 3 triangles, made them look like a trapezoid, and then he compared the 2 areas. That's a pretty nifty little proof for a squared plus b squared equals c squared. I like it. Okay, now we wouldn't necessarily write that one as a 2-column proof, right? That's not the way that was meant to be. It's much more meant to operate inside of the drawing, but you could write it as a 2-column proof if you wanted to. I'm just not going to take that time. I just think it's really cool the way that he put all that together. See how it goes. I can see this being a great bonus question on exam number 2.
Like working off the whole thing.
Yeah, like if I give you the picture, can you put together the area of the triangles, add those, put together the area of the trapezoid, set them equal, and work it out? Doesn't that sound like a great bonus question?
Yes.
Sounds great to me. I like it. And all I'm giving you. All right. All right. So there you go. That's kind of my look at the Pythagorean theorem. Of course, normally, and if you were working with kids in a classroom, that's not the way that would look with them probably. You would just be working problems similar to what they've got in the book with, there's a building and there's a ladder leaning up against it. Of course, we have to assume that the ground is flat, and we have to assume that the building is straight up and down, right? That makes me a right triangle. So if the base of the ladder is, I don't know, 12 feet away from the building, and the top of the ladder is 5 feet up, How long is this ladder? You know, things like that. Those are the word problem type things that you would probably do with kids, or it could be, I don't know, a telephone pole with guide wire, things like that. So you see a lot of those variations. So I'm not working those with you because I don't feel like you guys probably need that kind of work. But I think it is cool to see the President of the United States put together a proof of the Pythagorean Theorem. And that's kind of one of those cool little tidbits that you can use to maybe engage your students or motivate them, or just keep yourself motivated.
While he was in office?
You know, I think it was, but I need to look that up. Did he do it while he was in office, or was it pre being elected? That is a really good question. I don't know. I think it was while he was in office, but I cannot swear to that. Okay. So there's our Pythagorean theorem. I do want to do what I told you I was going to do, which is look at some preparation stuff and talk to you about the process for taking your
It was
test.
5 years before he was president.
It was 5 years before he became president. Is that what you found too? Y'all, it's like race to the Google. Here's a slower. Oh. So it was pre-presidential time. I bet if he had told them that he was nerdy enough to do that, they might not have elected him. I don't know. Nerdy. He was in Congress when he did it. Oh, very interesting. Didn't know. Now I know something else to tell my history students. All right. All right. They already covered this. All right. Let's talk about your state board exam. At some point, as you're going to become teachers, and I know not everybody in this class is going to become a teacher, but 99% of students in this class normally are. So at some point, whenever you're going to become a teacher, you have to take the TeXeS exam. And at least for right now, that's a two-part exam, where one is a professional exam, the PPR, where you talk about pedagogy and what you would do in a classroom and stuff like that. And that's what all of your student teacher time prepares you for, and all of your education class time prepares you for. So they deal with PPR. I don't deal with PPR. But if you're going to be either a math, middle school math, middle school, high school, middle school math, high school math, or if you're going to do the math and science combo, okay, then you have to take at least some version of the math test. Okay, so middle school math, high school math, or a math science combo. Then what you're going to do is at some point, somebody over there in the education department is going to tell you, okay, before you can take your content test, which is math is your content area, before you can take your content test, you need to take a practice exam, okay? And that's where I come in. I'm the one who approves you to take your practice exam. So when it comes time and you need to do that, you talk to Dr. Webster, okay? So for instance, there are people right now who are in the Math 460 class with Dr. Dibbs, and one of the things in her class is you have to have at least taken the practice content and preferably passed it, okay? For our purposes, what we've always seen as we compare people's results is that the practice test is actually a little bit harder than the real test. It's what we see. So our benchmark, so to speak, is 60% or higher is a pass. Okay, so we require that you take the practice test. You can take it here on campus with the testing center in the one-stop shop. Dr. Powell is in charge of that. And it's $30 right now for the practice test. Okay, and if you email me when you're ready to take the practice exam, I can send you the link for where to go to register, where to go to pay for it, how to do everything. And I will send you some practice materials, because even though it's, quote, only $30, still $30, and you don't want to waste your money. You don't want to go take a practice exam and just blow your attempt. You only get 5 chances. That's it. I've never actually had somebody run out their times on the practice exam. The most I think I've ever had somebody test was 3. So, but you don't want to spend that $30 over and over again if you don't have to. It's good to study beforehand, take it seriously, and go in and take the test. Okay. So, what about it? The practice exam is similar to the real test. Once you get the 60%, I send approval, and again, it's me, for the state exam. I'm the one that does it for math, okay? And also Dr. Wong, who's the department head, but normally we don't make him get involved in things like this. He's too busy being the department head. So state board exams run through Education North, which is, there's a center over there called the Educator Certification Office. Education North is the one that's right in front of the library. Okay. And I send them an approval. They go onto the TEA website and they flip a switch, basically. We used to call it barcoding, but now I don't think you have to do that anymore. You don't send a physical letter barcode anymore. You do it online. And so they flip a switch and then you go to the TEA website and pay your, I think it's $131 now to take the state exam. When I took it, I won't even tell you how long ago it was $80. And they just slowly keep on raising the price and raising the price. Last time it was $120. So I don't know where 131 came from. That's a really weird number. But yeah, so you pay your money and you find a testing site, hopefully near you, that offers the test at a time you can take it. There are some in Dallas that are set up a bit stringently. Like there's one where you can't even bring in pencils. They'll provide you with your pencils. But yeah, so depending on the structure of that particular testing site, you follow all of their rules, you go with your ID, stuff like that, just like you would around here for a testing center. And you take the test and hopefully you pass it. Woohoo! When you finish the PPR and pass it, then you are certified. That's how that works.
What is the timeline for this, like in relation to residency and or internships and stuff senior year?
So they keep on moving that. So I hate to be the one to tell you this and then be wrong. It used to be that during your residency, they made you take the PPR. I'm sorry, which one comes first? Internship, then residency. During your internship for middle school people, they make you take the PPR, and then during your residency, they made you take the content. I heard a rumor, so I'm not sure if this is true or not, that now they want you to take your PPR before your residency, like to already have it going. And I don't know which of your education classes that would be in where they would say, go now and do it. But supposedly there's a class where they.
I know one of my classes now we have a TeXeS like program and we have to go in and do practice tests for, I guess, the PPR, but I'm not sure.
So are you going to do the portfolio version? Yeah.
I haven't heard any information about any of this.
Yeah, so there is a new program that's coming down the pike. That's why I said for right now, this is how we do it. And I think it's part of the TCERT thing where you do a portfolio instead of taking the PPR exam. Yeah.
One of my classes required us to do that portfolio, and I know I have it bookmarked, but I never actually purchased like the actual program, or I'm not sure what it needs to be purchased.
Okay.
The actual portfolio portion of it.
Yes.
Because that's where like your practice exams that you do online on the TeXeS certification practice goes into that, and then they use it, I think it said during residency, like all your information is stored in there.
And I heard that that is completely replacing taking a PPR exam. But
Not yet.
eventually, yeah, I think they're piloting it now. The state of Texas, I guess they're just trying to get away from the high stakes testing aspect of it. And by doing a portfolio, it's something that's more cumulative, and you can put that together as you go. So that's kind of what I heard for the PPR process, is that's the direction they're headed. Yeah.
And just because we mentioned it on the practice exam,
Mhm.
is there a limit on the amount of times the PPR and the
The real exam, there is a limit. The real exam, I want to say it's also 5 times, but it could be 4. No, it's 5. I'm pretty sure, because I think that's why we have 5 on the practice. I have had people who went to take the state exam and just they freeze up, or there's a weird calculator thing in some of the tests. You have to use they now have it embedded inside of the test. And so you can't use your own calculator depending on your testing center. If it's a paper and pencil test, then you can. But if it's an online test, which most of the testing centers are now, then you're having to use their embedded calculator. You can go do a tutorial on that in advance and see how that runs, so that you're not stressed out at the moment that you get into the test going, oh my gosh, because I've had people go in and go, I can't do this because I don't have my 84, TI 84, which is what we're used to. So that's what I was going to say. There are some tutorials and different things like that you should do before you go to the state exam. I had one guy and one girl who have come down to the very, very last attempt. And I've told them, absolutely, you cannot take it again until you do study time with me. So like the first time, just go take it. You pass the practice, go take it. Second time, you really need to study, but okay, I'll let you take it again. But after the second time of failure, okay, now you got to prove to me, you got to put together a study plan, you got this, you got that. And by the 4th time, you got to come see me, because I don't want you to waste that 5th time. Now, I've been doing this for like 20 years, guys. And I've only had one guy and one girl come down to the last time. And both of them passed, by the way. After they came, we did study time together, like long study time, and they passed. So I really feel like for a lot of you guys, I've noticed some patterns. A lot of times it's vocabulary that's throwing you. Like you see a test question and it's like some weird vocabulary thing. You just, oh my gosh, okay, if I knew that, then I could do that. You know, it's not that you don't know the math, it's just that you're not lining up with what they want you to do so well. So usually people who study do okay. So, yes, ma'am.
What is it? Is there a time limit? Is there around the number of questions?
It's 80 questions, 5 hours max. And again, sometimes these things change just slightly. The 80 questions is 80 test questions, but sometimes they put in field questions. Yeah. So sometimes it's more than 80. So yeah, but yeah, 5 hours, you should be able to do 80 questions. So, okay. So with this in mind, I have loaded into your D2L a preparation manual. And this is the most recent that I know of. Math 4 through 8. Oh, I need to load. You know what? I have a couple of 7 through 12 people. I will load the 7 through 12 people 7 through 12 preparation manual also, so that because some of you are high school. I will load it. It's in the week 12 in your D2L. It looks like this on the front. And well, the 7 through 12 won't look like that, but it'll be similar. And the thing I want to show you is that as you go through, there are certain competencies, and every time you take a practice test or a real test, that's how they break it down, your results. So the competencies, this is on page 11 of this one. This study topics, chapter 3. Okay. Here is the testing framework. It tells you this is the 4 through 8 exam. This much percentage is geometry. Where's geometry? Geometry and measurement is domain 3. So right here, 21% of your test is geometry and measurement. That's almost a quarter, guys. So that's why we force you to take a geometry class, because you need to know this stuff, right? That's a lot of your exam comes from geometry. So here's the standards. Standard 1, number concept, standard 3, geometry. Here's the competencies, okay? So once you take a practice test or a real test, it'll say, this is number concepts. Here are all the competencies, competency 1, competency 2, competency 3. And you had 4 questions in competency 3 and you only got one of them right. And that's the way that they report that to you. So then you come into this little thing and you go, what is competency 3? Oh, competency 3 says I can use numbers to model and solve problems within and outside of mathematics. Okay, so I need to study how to use numbers to solve problems. Okay, so that's what, and I don't memorize this stuff. I don't care what competency 12 is until I get a student that's struggling with competency 12. And then we go, okay, what is it? And we go and we look and we see what's going on. Now, later in this manual, that was page 11. Later in the manual, starting around page 36, is a practice test. So before that, let me show you one page before this. This is your formula sheet. That's all you get. Okay. So if you need to know something like the area of a trapezoid, look, it's right there. They don't think you should memorize that either. Okay. So that's why I don't think you should memorize it. But if there's something else that you need to know and it's not on here, then make sure, oh, I need to know that. Okay. Memorize those things. Okay. But here you can see, here's a question. It's from competency 1. So that lets you know the kinds of things they're thinking you should be able to do from competency 1. And here's a question. Number 3 is from competency 2. Okay. So that gives you practice questions. And guess what? There's a solution key on page 58. There's your answers.
How many pages is that? Is it a lot?
The whole thing, because some of this is last minute study tips and reference dunk. It's 67 pages. So, but the practice test, if you just wanted to print the practice test, it's probably like 14. That's not that many. Probably not even that.
Part of the thing that you put in D2L.
I'm sorry?
It's part of the packet that you put in D2L.
It is all, I put the whole packet into D2L, yes. And I will load the whole packet for the high school as well. I just didn't think about it because normally it's my middle school teachers in here. All right, so that's the process for getting your state board exam. And if you run into issues or you think, oh my gosh, who can do this or who can help me with that? Normally, the person I work with over in education is Becky Adams. She does most of my middle school teachers for sure. And then if she needs something done with math, she normally sends them to me. So you can just ask me because you already know me. It's awesome. Okay. There we go. Now we have information about the test. And Samantha has practice problems, which I'll ask for. And we can work some of those. So if you get in there and we have time, probably on the review day before test 2, and you're like, hey, what about practice problem, blah, blah, blah. We can look at it. Yes, ma'am.
The review questions that we saw on review for exam 1, those would be questions, like examples of questions for the PPR exam.
Those actually came out of the math 1. So occasionally, this is actually a good question. One of the competencies, it's the last domain for math. It's called Mathematical Processes and Perspectives. And Mathematical Learning, Instruction, and Assessment. So those 2. So sometimes the questions, even though they're in the math test, they look a little PPR-ish, a little pedagogy. And that's why. It's because they're pulling stuff like that. And it says the beginning teacher will be able to blah, and tell the difference in these different positions or these different situations. What's the best, blah, blah. So it seems a little PPR-ish. There's not tons and tons of those in there, but there will be some that are kind of pedagogy in the math classroom specific. All right. Everybody good? I'm out of time. I'm actually running over on time and nobody's yelling. So let me call roll real fast. Make sure I got everybody. Ryan, you're good to go. and Ashley and Summer and Maria. I got all of y'all. If you have questions, hang around. Otherwise, I'm done once I call your name. Have a lovely afternoon. I'm stopping the recording.